All right, guys. We're going to talk about Unified IDE 2024. The VS Code environment, as you can see here, is available only on 2024. Earlier in previous version, we're going to have Eclipse-based environment. As you can see here, is for system build project, and for HLS, Vitis HLS, this was also an Eclipse-based and analyzer. Everything combined, we have a Unified IDE from 2024 onwards, and I think it's much better. I would say definitely. And in terms of application, you're going to have like as I said, it's combined in a single um, VS Code environment. So the host application, system project, and accelerated application is going to be in a single environment IDE, VS Code IDE, and you're going to have all the linker library, cmake settings. This is cmake based environment. Right now, we're going to focus on the accelerated application, that is the kernel files, and it's similar to, if we compare with the older version, it's very similar to Vitis HLS. Yeah, so let's focus on how to create this project on Unified IDE, right? So first of all, I'm going to quickly show the output that has been generated. So if I run this, and this is a command that is running internally, right? And let's go to add. Okay, it's not. Let's go to add, and then HLS, then implementation, then verilog. Yep. So these are the files that has been generated just now, right? So it just generated 12:35, as you can see here. Let's say via dot v. Yep. Yep. So as you can see, we have two interface, two input and one output. So for both the input, we have two XI interface, XI1 and XI2. This is XI4, and the output is shared with XI1. And same, we can see all the XI standard interface control signals, valid, ready, address. So I'm going to make separate video for XI stream, XI lit, XI 4 separately in separate video. Yep, so I'm going to close them. So that's it, and let me close this for now. So you have your flow setup here. If you want to, once we set up the remaining host application and system build project, we're going to have, when you click this drop down menu, you're going to have host menu, a host application, which looks something like this. Accelerated application like Vitis HLS, which we have it right now, which we did, and we don't have any test pen, so we're not going to run any simulation as such. And we have a system build project where we can build a final application and generate the .xcl bin files like we did here. Yeah, so this is command-based flow that we discussed in earlier videos right here, right? All right, so this was the video, and we deploy the application, command-based application. All right, so yeah, let me close this, and before we start, let us quickly go through the earlier command-based application. So what we did was open a new terminal, and we can go right here and cd. I made a copy of the seal pin files. Yeah, in the hardware copy. So I made a copy of this because build takes around 6 hours, I would say. Around 4 hours. Yeah. All right, so I'm gonna source this and I'm gonna run the application. Yeah, so test pass. So this is currently running on the actual hardware right here. So this U55C. So what? Yeah, let's see what application is running right now. Yeah, as you can see, this is the one that is running. Let me reset the application. Let's see, yes. And if we add some mine again, yeah, so there's no hardware running, right? Let me validate this. This is some of the application that is inbuilt when we install um, Control C. So this was automatically installed. Some of the test application when we install the driver, XRT driver. Yeah, so we stopped on DMA. So if we run this, so bandwidth definitely right. And let me stop right here. Okay, let it verify. Wait, sorry. Let's stop at verified. Yep. So now if I see, it should be verified. Cool. Now let's run our application again. Then definitely this would change to our application. App. And if I run, yep. So we have the app. Yes, I'm gonna close this terminal as well. Close window. All right. So let's come to the point. Did I miss anything? No. Okay. So we were just checking this and just to check what is the application. If you want to see what application is running on the card, you can run those commands. All right, so first of all, let me delete this directory that we just created. And let me open new terminal. Let us go to CD home. Yeah, so if you haven't cloned this tutorial, then you can clone it using this command on your home directory, right? Since I've already cloned, I'm going to go directly to this tab where I cd to example folder, and I'm going to source tools and enable the dev tools. This is important for compiling the host application because we have very old GCC version, G++ version. Yeah. All right, so let's launch the tools on the. Okay, we've got to create the directory. Yes. Now let's launch the tool. Alright, so as I mentioned, we have three things to create, right? One is HLS, one is the application, one is a system project. Like I just shown earlier, the system project, the host application, the accelerated app. This is the one that we're going to focus on for today. We're going to create the other two remaining in the next video. HLS, and let's say you can give any name. I'm going to give add empty file HLS config. So if you see here, this is the folder. It's going to generate only the log file right here. So we're going to track what are the files that is generated whenever we create a project or anything, right? So HLS config is one of the configuration file. We're going to see these files will be generated in one of the folder. And I'm going to add the design file, example, source, yeah, so the application file, this is the kernel, right? So we add, cool, this is the top function, click next, and click the platform. So we are using UFIT 5C, and 8 nanosecond, 12% clock uncertainty. Flow, we can either go for Vivado IP flow, where we can generate an IP so that we can import in the Vivado. This is for RTL designers, and for C++ software designers, this is where I'm going to use kernel flow for now. And .xo is the one that I'm going to choose. Next, finish. So this should generate a folder called vadd, and this is the config file that we just created, and this is the JSON file which is linking this. So if I open this, as we can see, the clock we have set 8 nanosecond and 12% clock uncertainty, and this is the kernel C++ application file, and we set the top function as vadd, and we want XO, and we want to buy this kernel flow, and this is the part number, right? So we have everything here, and we can see the same in the over here as well. If you click JSON, so there's nothing but just loading the config file, nothing much. If you click here, this is where everything part. If you want to change anything, you just click here and change the platform or part number, right? And everything right here, we don't have any test bands, and this is the source that we just imported, right? And yeah, so we can quickly run a synthesis. As I mentioned earlier, this is the command that is running internally. Yeah, synthesis has been completed successfully. Since we don't have any test beds, we're not going to run any C simulation or CRTL co-simulation. vadd, HLS, implementation, verilog. So these are the files that we just check, right? Yeah, so the control XI2, XI1, and the vadd application, the interface. Yeah, cool. Yeah, I think that's all for this video. Ciao, guys.